Good day, Doctor. My name is Heng, graduate number AF190247. So now I will present the company profile of our project. So the name of our company is known as FELIX, which is one of the leading consultancy companies specializing in geology and geotechnical engineering in Malaysia since 1999. And our team is made of highly qualified and experienced geology and geotechnical engineers to provide excellent consultancy services to our clients. Our clients comprise of both government and private sector in Malaysia and have been completed more than 300 projects including roads, expressway, airports, residential, commercial, industrial, retaining walls and even water dam. And our company is well equipped with latest software that could assist us in analysis, design and investigation purpose, and this will allow us to optimize the structure design and deliver more efficiency work for our clients. Our company philosophy is to deliver excellent services and committed in delivering quality works to all of our projects. And we are committed to ensure the clients understand and supportive of the way of the project involving our participation. So this is our company organization chart, where Moi Kin Fai is our founder and director, Kai Chuan is the assistant director, Liew, Zheng, Yong together with Heng are the geotechnical engineers, and Chia is a geological engineer. So the objective for our current project is to determine the load to be carried by every column, the suitable foundation design in the selected location, and to propose the foundation layout drawing details. Thank you, and that's all for our presentation. I'll pass to the next member to continue presenting.
A very good day to our lecturer, Professor MADYA TS Dr. FELIX LING. My name is Kai Chuan with mission number AF190246. Now I will continue with project background. This project is to construct a car showroom, a double-story office building, a rooftop car park, and a guardhouse, which are located in Jalan Kuala Kangsar, Ipoh. The whole new showroom is designed for BMW and Mini cars, and it will be the largest BMW showroom in Ipoh. Location of the project site is next to the Proton Service Center and near to the main road between Kuala Kangsar and Sungai Siput. Next, let's talk about the soil investigation report. The investigation carried out showed that the bedrock of investigation site area consists of limestone overlaid by a layer of embankment soil and X-mine soil. Observational data show that the top layer consists of 1.5 meter thick embankment soil layer, and layer 1 consists of X-mine soil which are thickness of 3 meter to 12 meter. The investigation carried out identified some factors for potential geological disaster that need attention, which are the presence of layer of loose to very loose sand, swelling care, and sinkhole. Based on the report, we have no objection on the development if appropriate mitigation measures are given attention according to appropriate guidelines, and the work carried out is under the supervision of professional geotechnical engineer.
Greetings and good day to Professor Maya TS Dr. Felix LING. I'm pleased to share our report's data analysis, which my name is Moi Kin Fai. The geotechnical report has identified two critical boreholes on the site, named as the BH1 and BH2 respectively. They utilize the electrical resistivity testing, SPT, and some geotechnical laboratory testing on figuring out the mechanical and chemical properties of the disturbed soil sampling in the boring. As previously mentioned, they discovered that the subsurface consists of clay, dense compact sand, and limestone. Some of the building specifications have been outlined following client specifications. The thickness of the slab on the ground floor and first floor is 100 mm and 125 mm respectively. The soil characteristics and the location of the heavy load cause the variation in the size of the column. Stump height varies between 500 to 1000 mm. The floor ground beams measure 225 x 600 or 125 x 600. High yield and mild steel are used as reinforcement for the in-situ concrete. So, each foundation with different axial loads shall be designed with an adequate number of piles, and each pile can withstand of a 230 kN load from the above structure. While coming to the chapter for design and analysis, the initial step in the design analysis process is to confirm the pile's ultimate load capacity. The shape of the pile is designed as a square shape. Using the listed general formula and a factor of safety value of 4, the ultimate load capacity of the pile can be calculated, as the result indicating that all piles in two different soils passed the check.
Hi, my name is Liew and today I will be presenting total settlement and factor of safety. In our project, we are using elastic settlement of piles, and the definition for the elastic settlement of piles is any soil settlement other than consolidation settlement. So the equation for the elastic settlement is SE1 plus SE2 plus SE3, where SE1 equals to elastic settlement of piles, SE2 equals to settlements of pile caused by the load at the pile tip, and SE3 is settlement of pile caused by the load transmitted along the pile shaft. And next we proceed to the equation, and here's are the equation for respective elastic settlement. And then I'm giving the example for borehole 1 in this calculation. So let's proceed to the borehole 1 calculation. And the allowable working load and skin resistance, we got it from previous session. So we just proceed the calculation, and then we just substitute all the parameters into equation SE1, SE2, and SE3. So in this example, SE1 we got the value of 7.83 millimeters, SE2 we got value of 3.18 millimeters, and SE3 we got 5.13 millimeters. And then we just summarize all the total settlement. Then we got 16.77 millimeter for borehole 1. So next proceed to the factor of safety. In previous session we have the Q design of 230 kilonewton. So and we already got the Q ultimate, which is equal to 788.19 kilonewton. So we just to calculate the factor of safety, we just have to divide the Q ultimate by Q design. So in this calculation, we got the factor of safety equals to 3.43, which is larger than 1. So this is can be acceptable. So that's all from me. Thank you and have a pleasant day.
Good day, doctor. My name is Pheng with matrix number AF190259. Now I will continue to talk about the discussion and conclusion of our project. Based on the calculation we had done, we have decided that deep foundation is chosen as a suitable foundation in this project, as there are inadequate bearing capacity for the shallow foundation. And deep foundation is more suitable as it could carry much more weight compared to the shallow foundation. Pile foundation is then chosen from several types of deep foundation that have been benefit to decrease excessive soil settlement and prevent the uplift forces. Those piles can transfer the load to underlying rock or stronger soil strata. Next, some consideration for designing foundation should be done. The design of deep foundation comes with two basic requirements, which are they must consist of sufficient safety against the failure and shall not undergo excessive displacement under the working loads. The following consideration is the ultimate load should always have greater value compared to the allowable loads against factor of safety, and the settlement must be kept within the allowable limits to reduce the possibility of excessive tilting and angular distortion of parts of the structure. There are two ways of soil improvement prior to foundation construction that we would like to mention. Firstly, dynamic compression that is involve a static weight that's range from 15 to 40 tons that drop from a specific height to produce dynamic effect on the soil. It's one of the most economical technique that can improve long-term performance, settlement, liquefaction, mitigation, and any others benefit. Second, recompression. Recompression is also proposed to improve the subsoil underneath buildings and embankments. This technique could prevent primary consolidation and portion of secondary compression, and following improve the shear strength of the subsoil by increasing the density and reducing the void ratio and natural water content. Next, special considerations such as water table fluctuation and foundation in sandslip deposits should be paying attention as well. Aquifer surrounding water bodies and rainfall can influence the development of water table. The rising of water can have effect on settlement foundation. If the water table rises and reach the ground level, the flood could occur as the water will seep through to the surface. While for the foundation in sand and slip deposits. Densification of the loose soil is needed. If not, the soil will flow away from the footing. If the soil is not confined, the density and the bearing capacity will lose. And the slip should be backfilled and compacted to propose a suitable foundation. Finally is the foundation. Foundation is crucial to one building long-term viability. If the foundation not done properly, it can have negative impact on the structural strength and the stability in long duration. So based on our judgment, we believe that deep foundation is more suitable compared to shallow foundation in this project, and the objectives of the project have been achieved as well. That's the end for our presentation. I would like to say thank you for the time to review our presentation. Thank you.